All right, guys, so warm-up number 20 reads, simplify to lowest terms and factor each number first. For number 1a, we got 8 over 24. 1b reads x squared minus 9 over x squared plus 5x plus 6. Numbers 2 and 3 is factor. For number 2 reads x squared minus 3x minus 18. Number 3 reads x cubed minus 5x squared minus 3x plus 15. Then from there, the instructions for number 4 reads solve for y and then evaluate when the domain is -1, 0, and 1. And number 4 reads -2y plus 14x equals -6. And number 5, it says add or subtract, and they give us 8 over 30 plus 5 over 20. Go ahead and copy those. I'll give you guys about 5 minutes. Ready and go. Started with number 1. For number 1, you should have gotten 1/3. Hands if you got that. Okay, good. Number 1b. Let's see. Hopefully you identified that the numerator is a difference of squares and you did square root of the first term. That is x times x. And then square root of the second term, 3 and 3. Oh, I was able to get both square roots. And if it's a subtraction, that means the identity for a polynomial, that this is a plus and this is a minus. Oh yeah, I remember that, Ms. Q. All right, good. All right, and that is over. I'm gonna factor this one. 6 goes on top, 5 on the bottom. 2 times 3 is 6, 2 plus 3 is 5. Yeah, so my factors are x plus 2 and x plus 3. And like I said the other day, that for the purpose of adding and subtracting rational expressions, I said you can use this shortcut instead of doing the factor by grouping. Yes. All right. Next. Identify the giant one. Here it is. And we're left with x minus 3 over x plus 2. All right. Hands if you got that. Okay, good. Yeah. Number 2, factor. Got -18 and -3. Factors of -18 that add up to -3. That is 3 times -6. 3 times -6, -18. 3 minus 6 is -3. So my factors are x plus 3, x minus 6. Hands if you got that. Let's go. Group. A little plus right there. GCF here is x squared. We're left with x minus 5. Plus GCF here is -3. We're left with x minus 5. So my factors are x minus 5, x squared minus 3. Hands if you got that. All right, good. All right. This one, once you solve for y, you should have gotten y equals 7x plus 3. Domain, we're going to use -1, 0, and 1. And for the range, which is all the y values, we're going to substitute these in here for x, each one. So -1 times 7, -7 plus 3, that's -4. 0 times 7 is 0. We're left with 3. And 1 times 7 is 7 plus 3, that's 10. Hands if you got that. Okay, good. And the one I do want to go over completely once more is number 5, because that's what we've been doing, but with polynomials. Here it goes again. Let me get a 8 over 30 plus 5 over 20. Let me do that on a separate page. Here it goes. 8 over 30 plus 5. Was it 5 over 20? Yeah, okay. All right, according to the home play that I gave you, what was step 1? Factor the denominators. Is that correct? Yes. So let's see, how can I factor 30? Well, I'm going to use a factor tree. 3 times 10 is 30, yes. And then 2 times 5, that's 10, and these are prime. So my prime factors for 30 are 2 times 3 times 5. Let me do that for 20. 2 times 10, 2 times 5. These are prime, so therefore my prime factors are 2 times 2 times 5. You're like, Mr. Q, this looks like the polynomials we've been doing. I know! All right, am I done with step 1? No. I said also identify the common denominator. Okay, first of all, look at this denominator and look at this denominator. What do they have in common? Oh, the 2 and the 5. The 2 and the 5. Okay, so what does this one need that this one has? Oh, this one has a 3, so I need to multiply this one times 3. Whatever I do to the denominator, I need to do to the numerator. What does this one need that this one has? Oh, it has an extra 2, Mr. Q, so I need to multiply times 2. Whatever I do to the denominator, I do to the numerator. I'm done with step 1. Step 2, I needed to rewrite each fraction. So I'm going to bring down my first numerator. What is 2 times 8? 16. And what is 2 times 2 times 3 times 5? That's 60. Plus, bring down the next numerator. What is 3 times 5? That is 15. 2 times 2 times 5 times 3, that's still 60. And now on step 2, we need to also add. How do we add? Oh, Mr. Q, we just combine the numerators. Yes, we combine. And the denominator is only 1 because we made it into one fraction. So what is 16 plus 15? 31. Can we reduce that anymore? No. That's why this would be simplified. That's Mr. Q. All right, good. So let's move on. Our agenda for today is warm-up number 20. Sum and difference of rational expressions. And your home play for tonight is play sheet 9.1, practice A, B, all only. And once again, if you notice on the top left of the screen, it says reminder for periods 1, 2, and 3, tutoring after lunch, 1 to 2, and it's free. Just saying, I'm telling you, yeah. All right, and once again, periods 4, 5, and 6, the days that we have the lesson, our tutoring is from 2 to 3. So make sure you get to tutoring. My goodness. All right. Your asynchronous code for Nearpod is WSU64. Asynchronous code is WSU64. Now, in that asynchronous assignment, I included a slide that you need to submit your warm-up, since you already did. You need to submit a Frere model for rational expressions, which is what we're going to do in a little bit. And also, I included one last problem from the presentation, which we're going to do right now, and 4 more blank slides. So all the extra problems that we do in this session, make sure you submit notes in those blank slides that I give you in the Nearpod presentation. All right? Yes, Mr. Q. All right, good. All right. So your previous home play was pages 433, 434, 15 to 22 only. Go to Canvas at this time, turn that in. And once you see when you turn it in, notice at the bottom of that assignment, I gave you the play sheet for tonight. So make sure you turn this in. Once again, the play sheet for tonight is play sheet 9.1, practice A, B, and that's in Canvas. So make sure you go there, get that. I'll give you guys a minute to turn that in. So with that said, our objective for today, I can add and subtract rational expressions. I can add and subtract rational expressions. We're still on rational expressions. So in your Frere model, write rational expressions, give me a definition, 1 example, 1 unexample, 1 hashtag. By now, you should be able to do that without looking at your notes. Am I right? Am I right? Am I right? Am I right? All right. I'll give you 1 minute for that. 1 minuto. Go. when we got started with rationals, I gave you guys a definition for rationals, which came from here. And it reads, quotients or rationals are the set of all fractions, here are the fractions, m over n, where m and n are integers. But in this case, now that we're dealing with rationals, they are what? Polynomials, yes? Yes, Mr. Q. However, what was the big thing that we needed to remember? That the denominator cannot equal to 0. The denominator cannot equal to 0. Why, Mr. Q? Because those are known as excluded values, the values of the variable that makes the denominator equal to 0. I'm bringing it up again because that's still something that we are doing, and that was on the home play last night or the night before. All right, from there I gave you guys steps, and here goes the steps once more. You already have these, you don't have to copy them. Step 1 was to factor the denominators completely, then make sure that we have a common denominator. Did we do that? Yes. Step 2, we needed to rewrite each fraction, and then from there we add or subtract. Step 3, we simplify by taking the giant ones. But between those two steps, I think I remember I told you guys to write factor or find the GCF of the numerator so that we can do the giant one. And last but not least, to identify the excluded values, we needed to write the denominator or, denominator equal to 0 and solve. All right, we got to this one, example 2, and then we went to this one. Then we went to that one. Then I skipped this one, and then we got to this one. Is that correct? That was the last one we did. However, today I want us to continue here, and I want you to write example 2 super duper Q. Write this down. X over x squared plus 4x plus 3 plus 1 over x squared plus 3x plus 2. I'm going to give you guys a head start to see how you do with that, and then I'll come right after to see if you're on the right track. I'll give you guys 2 minutes. Go. All right, let me start with Jaziel. So according to the process, the first step is to factor each denominator. Can you factor the first denominator? What'd you get?
I got, so 1 on the side and then 3 on the
and 3. So my factors are x plus 1, x plus 3. Thank you, Josiel. From there I went with who? Was it Victor? All right, Victor, what'd you get for the second denominator?
Like the Power Rangers right there, you put the 2 right there, and then 3 right there.
So factors of 2 that add up to 3?
And then you get 1 and then 2.
And 2, yeah. So my factors are x plus 1, x plus 2. All right, thank you. From there, who's next? Was it Addie? All right, Addie. So what do we have in common here and here?
X plus 1.
Yeah, so x plus 1 is what we have in common. So what does that mean that we need over here?
We have to add on x plus 3 to the one on the right and x plus 2 to the one on the left.
Thank you. X plus 3 for the denominator and numerator. And x plus 2 over here. And the numerator also x plus 2. That is correct. Okay. So we're done with step 1, which is factor and identify the common denominator. We have a common denominator now. Let me go to step 2. Step 2 says to rewrite the fraction. So if I start with this numerator and I write it here, what do I write, Octavio?
X squared plus 2.
X squared plus 2.
Oh, 2x.
Yes, over our common denominator, which is x plus 1, x plus 2, x plus 3. Plus, because it's a sum. All right. What else, Octavio? What goes on the numerator of the other side?
Uh, 1x plus 3.
1x plus 3 over the common denominator, which is x plus 1, x plus 2, x plus 3. Pass someone? So notice, guys, that we're still not done. We need to add now. What do I do next? Pass someone, Octavio?
Esmeralda.
Esmeralda. What do I do at that point?
You add x squared plus 2x plus x plus
Yes.
3.
We combine the numerators. Thank you, Esmeralda. And the denominators, we only write it as 1 because now we have only one fraction. X plus 1, x plus 2, x plus 3. So if we combine the numerators, let's see. X squared, is there another x squared? No, I write it there. 2x, is there another x? Yes, right there. So a total of 3x. And then a constant of 3, so we write plus 3. All right. Let's see. Esmeralda. So if I was to go on, so right there I already rewrote and I added those two fractions. Here it is. But in order for me to identify giant ones, what did I say to write above here? Pass someone, Esmeralda. What did I say to write above there?
Michael.
Michael, what did I ask you guys to write?
The GCF.
GCF or factor. Okay. Is there a GCF for the numerator, guys? Other than 1? No. Can we factor? Let's try. 2, 3, and 3. Factors of 3 are 1 times 3. Can we use 1 times 3 here to multiply to give us 3 and to add and give us 3? I see you guys nodding no, and some of you going like that. No, no, we can't. There is no such thing. So that means, Mr. Q, if we don't have anything, we are done. This is simplified. That is correct. All right. If we could simplify, then we would get 2 factors and then identify the giant one and simplify more. But at that point, we're done. All right, let's move on. Excluded values. All right. So who went last? Michael, pass
Me.
someone. Pass someone.
Victor.
Hector?
Victor.
Victor,
All right.
what do I write?
So you write x plus 1 equals 0,
Mm-hmm.
and then x plus 2 equals 0, and then x plus 3 equals 0.
And we solve, right?
Yeah.
minus 1, x equals -1, minus 2, x equals -2, minus 3, x equals -3. All right, so my excluded values are -1, -2, and -3. Yep, that looks pretty good. So one thing that I want to remind you guys, look up please, don't forget at this step after we add these to check to see if you can find the GCF or factor the numerator before you get to the giant one, okay? All right. Show me what how come you are with these. Yeah, okay. All right, so I'm going to take a step back and I want to go to, let's see, not that one. We did that one in class. Copy this one, example 2 mega cube. And for your asynchronous assignment, that one I labeled on the blank that I gave you. This is going to be example Q from the asynchronous. So when you get to that, it's a blank asynchronous and it says example Q, take submit your work. So take a picture of what we do here, okay? Yes, Mr. Q. All right. So here we go. Before I get started with these, writing utensils down, look up to the screen. Let me just clarify something because some of you are a little bit still not with the program in regards to difference of squares. Look up, please. Just pay attention. So when we got to polynomial identities, look up, I said one of the identities is x squared minus y squared. And I said the pattern for that will always be x plus y and x minus y. And some of you wrote it down and you didn't even maybe your noodle didn't process or I don't know, and you're having difficulty identifying these. But here's here's what it is. What it is that, look up, if I was to multiply these two parentheses, x plus y and x minus y, I would get this. But if I go the other way around to get from here to here, these are the things that I need to check. What do I need to check, Mr. Q? Well, first, to see if you can take the square root of the first term. What number times itself gives us x squared? Oh, x times x. The second thing that I would check is, can I take the square root of the second term? What number times itself gives us y squared? Oh, y times y. If you are able to take square root of the first and the second term, the third thing you're going to check is if this is a subtraction. If this is a subtraction, then that means that the first factor is a plus and the second factor is a minus, or vice versa. So what is the lingering question in your mind? Well, Mr. Q, what if this was a plus instead of a minus? If this was a plus, then we couldn't use this process to factor. This only works when these are subtraction. Okay, let me show you what it looks with numbers once more. Here it goes. X squared minus 100. Okay, what do you notice? It's a binomial. Okay, it's a subtraction. Let's see if I can use that process. Can I take the square root of the first? Yes, x times x. Square root of the second, 10 times 10. Okay, is it a subtraction? Yes, so that means this is a plus, this is a minus. Yes? Okay. Now, let me increase the rigor. Look up, please. X to the fourth minus 49. This looks kind of like this, but let's see if the process works. Look up. Square root of the first. What number times itself gives us x to the fourth? X squared and x squared. That is correct. Take the square root of the second. What is square root of 49? 7 and 7. Okay, so far it's working. Is it a subtraction? Yes, so that means this is plus and this is minus. Okay? All right. Roman, what are you doing? All right, let's go to the next one. X to the 6th power minus 81. Let's see if the process works. Square root of the first. What number times itself gives us x to the 6th?
X to the third.
Yes, x to the third times x to the third. Square root of 81. 9 times 9. Is this a subtraction? Yeah, so this is a plus and this is a minus. Is it a little bit clearer? Yes? All right, I just wanted to get that cleared because, like I said, some of you are still struggling with that identity. So hopefully that helped. So let's go to this one. Let's get started. Step 1, we need to factor the denominators. Okay, Ivan, what do you notice on the first denominator?
It's not standard form.
Boom, let's go. Should I say bam? So we write it in standard form, negative x squared plus 4. All right, let's factor it. Can we take this GCF, guys? Yeah, if this has a negative right here, then you need to extract a factor of -1, and we're left with x squared minus 4. Does that look familiar? Yes, Mr. Q, it's a difference of squares. Therefore, if we take the square root, what are my factors? X plus 2, x minus 2, and bring down the GCF, which is -1. Can I factor that anymore? No, I'm done factoring the first denominator. All right, help me with this one. Alyssa, what do you notice on the second denominator?
It's not in standard form.
All right, so standard form is negative x plus 2. Can we factor out a GCF? Yes, -1, and we're left with x minus 2. Can we factor anything else? No, we're done factoring the second denominator. So for step 1, we factored completely the denominator, but then we need to identify the common denominator. So what's the same here and here, guys? The -1 and the x minus 2. -1 and x minus 2. So what's missing?
X plus 2.
Yeah, on this side, we're missing the x plus 2. And whatever we do to the denominator, we do to the numerator. All right, so we're done with step 1. Let's go to step 2, which is rewrite the fractions. We bring down the first numerator, which is x squared. And my denominator is -1, x plus 2, x minus 2. This is an addition, so I put the plus. I bring down my other numerator, distribute this in here, so that is 1x plus 2. And my common denominator, I don't even need to look here, I just copy it here because we already found it. -1, x plus 2, x minus 2. All right, we're done rewriting. Now we need to do what? Add. What do I do to add? Bianca.
You add both numerators?
Yes, combine the numerators. Thank you, Bianca. Add or combine. And the denominator, we only write it once. -1, x plus 2, x minus 2. So can we combine anything here? Not really. We just combine them all together and write them as is. X squared plus x plus 2. So far, so good? Yes? All right. Alberto, what did I ask you guys to write at this step? What did I ask you guys to write there?
Excluded value.
No.
Oh, no. Distribute the, wait, I don't know.
Okay. Just yell. What did I ask you guys to write?
Find the greatest common factor.
Greatest common factor or
Factor.
Or factor, yeah. Let's see if we can factor or find the greatest common factor. Is there a GCF other than 1 for the numerator? No. Let's see if we can factor it. We got 2 and we got 1. Factors of 2 are 1 times 2. Can those be added to give us 1? Are there any two numbers that multiply give us 2 that we can add to 1? No. So that means if this cannot be factored anymore, then we're done with our simplification. This is simplified. All right. Now we do the excluded value. Excluded value. I'll write the first one. The first one is -1 equal to 0. Is that true? No, so this is eliminated. What else do I write, Roman?
X minus 2 or x plus 2 equals 0.
And?
X minus 2 equals 0.
Thank you. And when we solve, guys, our solutions are -2 and 2 as our excluded values. Woo, this was a nice one. Let's go. All right. So once again, we label this one example Q, just so that you can submit your notes for your asynchronous assignment. All right. So far, so good, yeah? So is the process becoming a little bit clearer now? Yes. So what is the one thing that you maybe kind of skipped on the home plate? This part right here, look up, make sure you make a note. When you get to this part, make sure you try and check for a GCF or factor on the numerator before you get to the giant 1. Because that's where some of you, if you were driving, you would be running a red light right there. My goodness. All right. All right, let's move on. So at this point, get your home play in front of you from last night. But I do want you to, whatever problem that we choose, I want you to do that completely again so we can get the extra practice. So I'm going to open it up for you guys. So which one do you guys want me to go over together with you guys? Okay, let's go over number 18. Copy that one. All right, there's number 18. Copy that. But instead of labeling 18 for our synchronous assignment, is going to be our example super cute. So when you get to the slide on the synchronous assignment, and if you see example super cute, you're going to submit the work for this one. All right, let's see. Step 1, we need to factor the denominators. Okay, so look at this denominator. It's a binomial, but does it have a subtraction in between? No, so we can't use the square root method, right? And since it's not a trinomial, we can't use the Power Rangers. Does it have a GCF other than 1? No. So guess what? This is simplified as much as we can without being able to factor it. What else do we notice? That we have a common denominator. All right, so do we need to do anything to the denominators? No. Let's go to step 2. Step 2 is rewrite. All right, I'm going to help you with the first one. I'm going to bring this one down. 4x to the 4th plus 4 over x squared plus 1. All right, Alberto, help me rewrite the second one. What do I write for the second one?
Plus -8 over x squared plus 1.
Bam, plus -8 over x squared plus 1. Let's go, Alberto. You remind me of me and Kinder. All right. So, so yeah, because we need to distribute this negative to the numerator. Is that correct, guys? Yes. All right. So now let's add. Add. What do I do?
You add 4 and -8. You combine them.
You combine the numerators, 4 and -8, so that gives us 4x to the 4th and minus 4 with the same denominator, x squared plus 1. Okay. All right. What do we do at that point?
You can factor the numerator.
Factor and check for GCF. Okay. Do we have a GCF on the numerator, guys?
Yeah.
Yes, it's 4, and we're left with x to the 4th minus 1. Can we still factor that? Yes. Esmeralda, what'd you get for the factored form? We still have 4. And what are my two factors?
X squared plus 1 and x squared minus 1.
Let's go. And that's going to be over this denominator, which is x squared plus 1. All right. Identify the giant one. It's right there. What do we have on the numerator? We have a 4 and x squared minus 1. 4x squared minus 1. And all that over, since we factored out the 1, we're left with 1. Now, can we factor this numerator more? Look at it.
You put x plus 1 and x minus 1.
Let's go. Yes, because we take the square root of this and this again, and it's a minus. Yes. So this, we're done. Okay. Let's go to the last thing, excluded value.
There is no excluded value because 1 cannot be equal to 0.
No excluded value. Why? Because there is no variable in the denominator. Yeah, because if we write 1 equal to 0, is that true? No. It's not. All right. Show me your fingers. How come through our with these? Yeah, we good. Yeah. Okay. 4 5s, 4 5s. All right. I'm gonna stop right there. I was gonna do one more, but I'll stop right there just for the sake of time. And once again, guys, reminder: if you need to attend tutoring, tutoring after lunch, make sure you get there. And your home play, once again, where do you get your home play? At the in Canvas. So once again, your home play is play sheet 9.1, practice A-B. All right. Your synchronous assignment, once again, your code is WSU64. Have a good one, guys. Enjoy your home play. See you guys till next week. Oh my goodness.